All right, welcome to The Explainer. Today we're diving into something I think is just so cool. It's a smart greenhouse, a greenhouse that can literally take care of itself. We're going to break down how a simple do-it-yourself project can use the Internet of Things, or IoT, to completely automate plant care. So let's get right into it.
So let me ask you this. Could your garden water itself? I mean, really think about that. You go on vacation, and back home, your garden just knows when it's thirsty and gives itself a drink. It sounds like something out of a sci-fi movie, right? Well, it's not. That's the core idea we're unpacking today. A system that can actually sense its environment and then act all on its own.
And here's the really incredible part. This kind of smart tech, it's not just for giant corporations or huge industrial farms anymore. Nope, because all the little pieces that make this work are now so cheap and easy to get, the power of smart farming is basically in everyone's hands. We're talking large-scale growers, sure, but also you, me, the backyard hobbyist.
Okay, so how does this whole thing actually work? Well, like any smart system, it needs a command center, a brain. And for our little greenhouse project, we've got a tiny but really powerful brain that's calling all the shots.
And here it is. This is the ESP32. Just think of it like a tiny computer on a single chip. Now, technically, it's a microcontroller, which just means it can run programs. But its real superpower? It's got Wi-Fi and Bluetooth built right in. So it doesn't just think, it communicates. And that, right there, is what makes it the absolute perfect brain for an Internet of Things project like this.
So why is this little chip such a total game changer? Well, for starters, it's super cheap, but still really powerful. And having that Wi-Fi built in saves you a ton of extra work. Plus, it's compatible with the Arduino platform, which a lot of you probably know, and that makes it incredibly easy to program. It's kind of like building something really complex, but with simple Lego blocks.
Now, of course, a brain isn't much good on its own, right? It's only as smart as the information it gets. So for our little ESP32 to make intelligent decisions, it needs senses. We need to give our greenhouse a way to see, to feel, to perceive the world around it. First up, let's give it a sense of, well, let's call it thirst. This is a soil moisture sensor, and it's so simple, but so clever. You just stick these two prongs into the soil. See, water conducts electricity, so the sensor just measures how much electricity is flowing between the two prongs. The more water, the higher the conductivity. It's really that simple. It's how the system knows if the soil is thirsty. Okay, next up, sight. Let's give it some eyes. This little component is a photoresistor, which is just a fancy name for a light-sensitive resistor. When it's dark, its electrical resistance is super high, but when light hits it, that resistance drops way down. This is exactly how our ESP32 brain can tell if it's a bright, sunny day or if it's getting cloudy and dark. So, you might be wondering, how do these sensors actually talk to the brain? Well, they use one of two kinds of signals. A digital signal is super simple. It's either on or off, a 1 or a 0. Think of a regular light switch. But an analog signal, that's different. It's a continuous signal that can represent a whole range of values. Think of a dimmer switch, you know? You can slide it from dim to bright and everything in between. And that's perfect for measuring things like moisture or light that change gradually. Okay, so let's recap. Our system has a brain. It has senses. It can gather all this data about its world. But, so what? The real magic, the whole point, is when it acts on that data. To do that, it needs some hands, a way to actually interact with the physical world. So how does it go from a decision to an action? The answer is this little guy, a relay. Here's the deal. The ESP32 brain runs on just a tiny bit of power, not nearly enough to switch on something big like a water pump. So the relay acts like a bridge, or maybe more like the muscle. The ESP32 sends a tiny low-power signal to the relay. That signal flips an internal switch inside the relay. And that switch can handle a much bigger, high-voltage current to power up the pump. It's the brawn to the ESP32's brain. And this is where it all comes together, with some really simple but powerful if-then logic. The code we write just follows a basic set of rules. For example, if the soil moisture sensor says the soil is dry, then activate the relay to turn on the water pump. Or, if the light sensor says it's too dark, then turn on some extra LEDs. It's just a beautiful, simple chain reaction. Sense,
think, act. All right, so now our greenhouse is autonomous. It's running on its own, but it's still kind of in its own little bubble, right? To make it truly smart in the IoT sense, we need to connect it to the internet. We need to be able to check on it from anywhere. This is where we build the system's central nervous system, connecting all the pieces together.
The ESP32's built-in Wi-Fi uses the 2.4 gigahertz band, and you've probably seen this on your router at home, right? You have the 2.4 and the 5 gigahertz options. Now, 5 gigahertz is way faster, for sure, but its signal is terrible at going through walls or over long distances. For a little device like this, which might be out in your greenhouse or your yard, the longer range of the 2.4 gigahertz band is exactly what you want for a solid, reliable connection.
And obviously, for that connection to actually work, you need a good Wi-Fi signal. This chart here just shows you how that signal strength is measured. You don't need to get bogged down in the numbers. The key thing to remember is that anything below -70 is probably going to be unreliable. Basically, for your smart garden to send its data, you got to put it in a spot that gets a decent connection, just like you would for your phone or your laptop. Okay, so the data is being collected, it's being sent over Wi-Fi, but where is it going? Well, it gets sent to a cloud service. In this case, we're using one called ThingSpeak. The best way to think about ThingSpeak is as a personal dashboard for all your internet-connected things. It's specifically designed to catch the data from our ESP32, hang on to it, and then turn it all into these really simple, easy-to-read charts for us. So let's just trace that whole journey one more time, from start to finish. Step 1, the sensors sense the environment, the moisture, the light. Step 2, the ESP32 brain processes that data. Step 3, it uses its Wi-Fi to connect and send that data to the cloud. And finally, step 4, ThingSpeak lets you visualize all of it on your phone or computer. Sense, process, connect, visualize. From the dirt straight to your dashboard.
And what you get at the end of the day is a dashboard that looks something like this. It's just a clean, super simple view of everything you need to know all at a glance. You could be at work, you could be on vacation on the other side of the country. As long as you have an internet connection, you can pull this up and see exactly what's going on with your plants in real time. It's pretty amazing. You know, this quote really captures the bigger picture perfectly. This little greenhouse project, it's more than just a cool gadget. Each one of these small, smart devices, it's like a single nerve ending. And when you connect them all up through the internet, they start to form a new kind of nervous system for the planet. It lets us see and monitor and manage our world in ways that were honestly impossible just a few years ago.
And honestly, this is just the beginning. The tools to build these kinds of systems are here, right now. They're cheap, they're accessible, they're incredibly powerful, which leaves us with a really big, fascinating question to think about. When every farm, every garden, maybe even every single houseplant, when every object can sense, process data, and act on its own, what comes next? What kind of world will we choose to build with that power? Thanks for joining us on The Explainer.